Welcome back to the channel. This video, I am going to give you full detailed discussion on Cambridge International AS Physics, May June 2024, paper 1-1. So are you ready to get started? Let's start. Now, question number 1, which unit is an SI-based unit? Remember, you are asked to memorize six. There are 7 base units, but you are asked to memorize 6. That's being covered in your syllabus. What are the 6 base units? First one, mole, amount of the substance. The other one is kilogram, mass, meter, distance, Kelvin, temperature, ampere, current, 1, 2, 3, 4, 5, and the last one, second. That's the SI base unit of time. So these are all the 6 base units that covered in your AS syllabus. Please make sure that you memorize this. Therefore, the answer is A. Number 2, which of the following could have the same units as force? First of all, I remember force as, if you don't want to use the SI base unit to get the SI base unit of force first, and then you do one by one to get the SI base unit of energy, and then SI base unit of distance, which it is more time consuming. Now, there is a faster way in doing so, right? So how? Right, let me show you. Force is defined as the rate of change of momentum. This is how the force is being defined. Now, I see a lot of energy here. That is why I want to use energy first, because force is definitely not momentum multiplies by distance, and it is not momentum multiplies by time, because force is related to change in momentum. So say no to C or D. Now, since it is related to energy, I would like to define the work first, because work can be related to force. Work is defined as the product of force and distance moved in the direction of force. Now, work or energy is ability to do work. So energy is actually equivalent to work. Force, in this case, force is equal to work divided by distance, or in other words, because energy is equivalent to work, that is why you can put energy per distance. That is also equals to force. A is the answer. Or else, the second method is that you have to come up with the SI based unit of force, which is kilogram meter per second square. And then you have to do one by one for A, for B, for C, and for D to come up with their own SI based units. And then you compare, right? The homogeneous, right? So you homogeneity. So you compare this unit and the unit of force. If you get the same unit as the unit of force, that's the answer. Question number 3, the velocity of an object changes from initial velocity u to a final velocity v. The vectors represent this velocity. Which single vector represents the change in velocity? Change in velocity. Change in velocity has to be final velocity minus initial velocity. That is what we call change in velocity. So final velocity, I'm just going to draw my arrow downward first for final velocity. But due to this is negative u, because I have to minus the initial velocity, it seems like v plus negative u is actually the same. So u is towards right, negative u will have to move to the left, like this. Therefore, the resultant or the change in velocity, you start from the first force, that first vector that you the tail of the first vector all the way down to the tip of the second vector. So this is C. Question number 4, an object is moving with initial velocity u. The object then moves with uniform acceleration a for time t until it reaches final velocity v. Which equation describes the motion of the object? If you don't remember this, you can actually scroll out to one of the equation here, which is given. They didn't give you, but it's okay. The definition of acceleration will do. Acceleration, because they give us an acceleration, A is equal to V minus U over T. You can actually use AT is equal to V minus U. Since the V or U must be the subject, I put V as a subject first. V is equal to U plus AT. But I look at C and D, there are no equation related to V equals to U plus AT. So say no to C or D. Now, okay, never mind. Now I want to put U as my subject. So AT minus V is equal to negative U. Therefore, U is equal to V minus AT. I got B as the answer. Question number 5, which calculation produces a vector quantity? Current, let us look at current. Current is a scalar times scalar. So it will produce current times time, Q equal to IT. So this is a charge actually. So IT, Q it, Q equals IT. This is a charge. Charge is a scalar quantity. What about final displacement minus initial displacement? That is a change in displacement. Change in displacement, because displacement is a vector quantity. Therefore, the change in displacement is also a vector quantity. I'll say yes to B, but I'll prove C and D are wrong. How about that? Work done, work over time, energy divided by time, right? That is power. Power is a scalar quantity. Therefore, C is not your answer. Half time mass times speed square, that is your kinetic energy. In fact, all the energies, all the work, right? They are not vector quantity. In fact, they're scalar quantity. So D cannot be your answer as well. Therefore, the answer is B. Number 6, a thermometer can be read to an accuracy of plus minus 0.5 degrees Celsius. This thermometer is used to measure a temperature rise from 40 degrees Celsius to 100 degrees Celsius. What is the percentage uncertainty in the measurement of the temperature rise? Now, to find the temperature rise, I have to do it one by one. Temperature rise. How do we find temperature rise? We take the final temperature minus the initial temperature. So final temperature minus initial temperature, temperature rise, you get 60 degrees Celsius. Now, and then to find the absolute uncertainty, because this thermometer comes with absolute uncertainty. Since the mathematical operation involved here is only about subtraction, right? To find delta or absolute uncertainty of the temperature, I'll put here temperature rise, you just add out their absolute uncertainty. So 0.5 degrees Celsius plus 0.5 degrees Celsius. So 1 degree Celsius is the delta temperature rise, or the absolute uncertainty of temperature rise. Now, what is the percentage uncertainty? Percentage uncertainty of the temperature rise will be absolute uncertainty, which is 1, divided by 60, which is the temperature rise, times 100%. And you should get 1.67%, or you can round it off to 1.7% as the answer. D is the answer. Number 7, the diagram shows the path of a golf ball. Which row describes changes in the horizontal and the vertical components of the golf ball's velocity when air resistance is ignored? Now, this is a curved motion, which we call it as parabolic motion or projectile motion. For projectile motion, the horizontal velocity must always be constant. So it is either C or D, whereas vertical, on the other hand, the acceleration must be constant, right? So the acceleration must be constant, which is C. So due to the horizontal velocity being constant, right, added with vertical acceleration being constant, you get this type of motion. We call it as curve motion or projectile motion. Question number 8. An aircraft flies from London to Sydney in a time of 21 hours, 40 minutes. The distance travel is 17,000 kilometers. What is the average speed of the aircraft? First of all, I need to get the average speed first. Now, since all the values given in the units of average speed given in meter per second, I have to change my time to meter per second. Right, so this is 21 hours. I have to change it, okay, to minute first, right? So you take 21 hours, you times 60, which gives you 21 times 60, which give you 1260 minutes, plus with this 40 minutes. So you get 1300 minutes. So from minutes, you can change to second very easily. Right, so average speed, I write it here, is this actually equal to total distance traveled by the aircraft divided by the total time taken. Total distance travel, it is in kilometers, so I have to change it to meter. 17,000 times 1,000 because I want to change that kilometer to meter. And then this is 1,300 minutes. I want to change it to second. I just times 60. And I got 2.18 times 10 to the power of 2 meter per second. That is the average speed of the aircraft. Now, I don't say the answer cannot be A because this is only 2.2 meter per second. I have to look at B, C, and D, and B, C, and D involves prefixes. So I have to do it one by one. So for B, 2.2 times 10 to the power times 10 to the power of 7. You have to be careful. It's not negative 7. Mu. This is one of the prefixes, micro, which carries the power of 10 to the power negative 6 meter per second. So when you work it out, you should get 2.2 times 10 to the power of 7 plus negative 6, you get to the power of 1 meter per second. It is also not B because I want 2.18 or 2.2 times 10 to the power of 2. I round it off to 2.2 times 10 to the power 2 meter per second. Now, what about C? 2.2 times 10 to the power 11. Nano is one of the prefixes, which is 10 to the power negative 9 meter per second. And then you simplified it, you should get 2.2 times 11 plus negative 9, you get 2 meter per second. So the answer is actually C, but I'm proving that D is not the answer. 2.2 times 10 to the power 6. Milli is one of the prefixes, which is 10 to the power negative 3 meter per second. So this is 2.2 times 10 to the power of 3. 6 plus negative 3 gives you 3 meter per second. Therefore, the answer is C. Number 9. A golf club hits a golf ball. The graph shows how the force F on the ball varies with time t. Which graph shows how the velocity v of the ball varies with time t? Now, I want you to see this. Whenever there's a force, there is an acceleration. So in other words, I can say that force is directly proportional to acceleration. Force increases, acceleration will also increase. So I will relate the acceleration to the velocity. So how to relate the acceleration to the velocity? From the velocity time graph, the gradient of the velocity time graph gives you the acceleration. Now, I would do this part first because the acceleration is increasing due to the force that is increasing. Therefore, okay, for the velocity time graph, it cannot be C because the velocity is constant. If the velocity is constant, horizontal line will give you 0 gradient. Therefore, 0 acceleration. D cannot be your answer as well because it is a straight line graph. The gradient of the straight line graph is always constant. Therefore, the gradient of the straight line graph, which represents acceleration, will also be constant. C and D are not your answer. Let us look at A and B. I will have to choose B. Do you know why? Because you look at the value of force, start from origin. Therefore, the value of acceleration must start from origin. Whereas A, when I draw a tangent, I couldn't get 0 initially. But B, you look at this part of B, it is actually horizontal line. So it actually starts from 0. Therefore, B is your answer. And here, due to the tangent line that is increasing, your acceleration is increasing to maximum and then drop to 0 again when the line is being horizontal. B is the answer. Question number 10. What is meant by the mass and by the weight of an object on the earth? Right? So let us see. Is momentum divided by velocity? Is that mass? The weight is not work done in lifting it in 1 meter. That is not work. Weight is a force. B, the gravitational force. Mass is not the gravitational force. One wrong, other one will be wrong as well. Right. C, the pull of the earth on it. Nothing to do with mass. It has something to do with weight. D, the property that resists its acceleration, which is inertia. Inertia can be measured by using mass. There is no apparatus to measure inertia because it is very subjective, right? So larger inertia is due to the larger mass. That is how we see, right? So yes. And weight, the pull of the earth on it, it is also true. Therefore, the answer is D. Question number 11. A thin horizontal plate of area, I better write it down first, 0.036 meters square is beneath the surface of a liquid of density 930 kilogram per meter cube. The force on one side of the plate due to the pressure of the liquid is 290 Newton. What is the depth of the plate beneath the surface of the liquid? Now I need to find, since they asked about the depth, okay, this is a force on one side of the plate due to the pressure of the liquid. This force is actually upthrust force. So if you remember the equation of the upthrust force, F is equal to rho VG. I'm going to use that. F is 290, rho 930, V is the area times the depth, right? So times the depth of the liquid. So I will just put H here and G. So 290 is equal to 930. Area is 0.036 times H times 9.81. So you're going to make H as the subject. The H that you get must be 0.883 meter, which you round it off to 0.88 meter. A is the answer. Now, question number 12. Sphere X and Y form an isolated system. Isolated system means closed system. That means we ignore all the resistive forces that could be acting on sphere X and Y. The mass of Y is greater. I will have to write this. The mass of Y is greater than the mass of X. Sphere Y is initially stationary. Sphere X collides elastically. Wow, this word is very important. Elastically with sphere X. The speed of, okay, I will just write X first, X. And then the speed of X before the collision is U. This is Y, which is bigger. And then this is before and after, I don't know. Which statement must be correct? So when you see this word elastically, so for elastic collision, three conditions must be fulfilled. First one, the total momentum before the collision must be equal to the total momentum after the collision. Principle of conservation of momentum must be obeyed in this case. Second, the total kinetic energy before the collision must be equal to the total kinetic energy after the collision. So the principle of conservation of kinetic energy must also be obeyed. Due to the kinetic energy, the total kinetic energy, which is constant, and the total momentum, which is also constant, right? We can derive the relative speed of approaching equal to relative speed of separation. So the relative speed of approaching must be equal to relative speed of separation. In this case, the relative speed of approaching is the speed of x, which is u. And the relative speed of separation could be, must be, because they say that y is moving. We assume that y is moving. So it is Vx plus Vy. Now let us look at A. Sphere X rebounds with a speed that is greater than u. Could you see that this is u? Let's say the speed of X is 20, let's say. And the speed of X after that, maybe it is 5, and the speed of never mind, the speed of X maybe is 15 after that, and then plus with 5 speed of Y. So could you see that, right, to get that 20? Therefore the speed of X rebounds cannot be greater than u, because the speed of X rebounds must be added with the speed of Y, right? Which is equal to u. This is wrong. A cannot be your answer. B, the speed of rebounds. A sphere X rebounds with a speed which is less than u. This is true. 15 is less than 20. And sphere Y moves off with a speed which is also less than u, which is true. This one must be true. C, sphere X rebounds with speed U and sphere Y remains stationary. I don't say this is wrong, but I'll prove it from the principle of conservation of momentum. So momentum, sphere X move mx, this is U. Sphere Y is stationary. So after the collision, sphere X rebounds. So sphere X rebound, it has to move in the opposite direction with negative U. Remember? Because momentum is a vector quantity. And sphere Y, it remains stationary. Could you see? This is mx negative U. Mx U is not equal to mx negative U. So that is wrong. D, sphere X remains stationary and sphere Y moves with a speed that is lesser than U. So if you move with a speed which is lesser than U, then I will have to say that, okay, this is X stationary. After the collision, Y will move with the speed which is lesser than U. Okay, so I'll put in number, maybe mass of X, maybe 1 kilogram, and which is moving with U. This one I put, okay, to see whether this is correct. U is maybe 20. And then Y, maybe the mass of Y, because mass of Y is greater, 2 kilogram. So this is less than U, maybe 5. Let us see whether it's true or not. So total initial momentum is the momentum of X, which is 1 times 20. So it is 20 kilogram meter per second, which is equal to mass of Y, 2 times 5, lesser than U. So 2 times a value which is lesser than U. Could be 3, if it is larger than U, let's say 2 times 20, oh, cannot be 40, it has to be 40. X remains stationary, but okay, when we think it logically, how can X remains stationary when the mass of X is actually lesser as compared to Y. So if you think it logically, you take a smaller object, collide with a larger object. How can the smaller object be stationary and move the larger object? Most of the time, the smaller object will rebound or move together, but since this is elastically, maybe not sticking together, maybe mass of Y will move a little bit, but mass of X will also moving. So this is a little bit not logical. So D cannot be the answer. Therefore, I choose B as the answer. Question number 13, a ball of mass 0.1 kilogram is thrown towards a stationary vertical bat. The ball hits the bat with a horizontal velocity of 20 meters per second. The ball rebounds and leaves the bat with a horizontal velocity of 15 meters per second. What is the change in momentum? Remember, this is a symbol of momentum, small little p here. Delta means change. So it has to be the final momentum minus initial momentum. Mass of the ball is 0.1 kilogram, so I don't have to worry about that. But you have to bear in mind, this is a final velocity. This is the initial velocity. So when I talk about final velocity and initial velocity, velocities are vector quantities. Therefore, you need to consider the direction. I will consider to the left as positive. Therefore, to the right, we'll take negative. So I will put 0.1, positive 15, minus 0.1, negative 20. So here I get 0.1 times 15. I got 1.5 minus 0.1 times 20. I got negative 2. Could you see that? 1.5 minus negative 2, it gives you 1.5 plus 2. Therefore, the answer is 3.5 Newton second. D is the answer. Question number 14. An isolated object of negligible weight is acted on by two coplanar forces of the same magnitude. In which diagram is the object in equilibrium? For an object or a system to be in equilibrium, there are two conditions to be fulfilled. One is the resultant force acting on the system or acting on the object must be equal to 0. Second condition is that the resultant moment acting on the object or on the system must also be equals to 0. Let us look at A. They told you that these two forces are of the same magnitude. So one force is going downwards, is balanced by the outward force. So A could be in equilibrium. B, one force down, one force is upwards. B could be in equilibrium as well, but C cannot be in equilibrium because two forces are acting outwards. There is no downward force to balance the downward force. So C cannot be the answer. D, one force is acting downwards. There is no upward force to balance it, and there is also no left force to balance that, right force to balance that left force. D is also not the answer. Now, so since we have two answers, right, we have to use the principle of moment to solve, yeah, to find for the exact answer. Let us look at B, right? So B, it seems like these two forces of the same magnitude acting in opposite direction, and they are being separated by a distance. It seems like these two forces of B makes a couple. So couple will produce pure turning effect. It will never produce equilibrium, right? B cannot be the answer, therefore A is the answer. Question number 15, a uniform beam PQ rests horizontally on a support at point S. A rope is attached at one end of the beam. The rope is at an angle of 60 degrees to the vertical and exerts a force F in newtons on the beam. What is the moment in Newton meter of the force about point S? About point S, meaning to say that S has to be your pivot. Now, I have to resolve this force because I have the distance, and that distance must be, okay, this is the distance between the force and perpendicular distance between the force and the pivot, the one that I highlighted yellow. How do I get that distance? I take 2.5 meter minus 0.3 meter, right? So I take 2.5, oh, sorry, this is 2.5. 2.5 meter minus 0.3 meter, that gives you 2.2 meter. So 2.2 meter here. I have the perpendicular distance, but my force, I have to resolve in the vertical direction because the distance is horizontal. So to resolve in a perpendicular distance, I use adjacent. So it is F cos 60, right? So F cos 60, so moment is equal to the force F cos 60 times perpendicular distance, which is 2.2 meter. I got 1.1 F. So 1.1 F is A. Now, question number 16, the diagram shows the dimensions of an elastic cord used to project a stone. Tension in the cord is T when the cord is pulled into the shape shown. Which force does the elastic cord exert on the stone? So this is the force that I want to find, exert on the stone, because eventually the stone will move horizontally. So I have to resolve T in the horizontal direction. Now, how do I resolve T in the horizontal direction? This is 90 degrees. I am using this T first. Now I use this T. This is T cos adjacent. T cos, the upper T is T cos theta. Plus the other T, which is, yeah, also going to the right in the same direction. T cos theta as well. So this is the force, right? Elastic cord exert on the stone. So the tension, I don't have the value of tension, but cos theta, I want you to see this. This horizontal line is 6 cm. Cos adjacent, yeah? So you use 6 cm divided by 10 cm hypotenuse. Plus T, 6 divided by 10. So you get, okay, 6 over 10 plus 6 over 10. 6 over 10 times 2. So you get 6 over 5t. 6 over 5t is the answer, which is B. Question number 17. A box of weight 40 Newton is pushed with a horizontal force of 20 Newton. I will write it here. 20, this is 40 Newton. And this is the force, 20 Newton to push it. Along level ground for a distance of 2.4. Okay, 2.4. Okay, this is 2.4 meter. The box is then lifted at constant velocity through a height of 1.6 meter by a vertical force. Wow, it is being lifted outwards. 40 Newton, right? Okay, the distance is 1.6 meter by a vertical force. What is the total work done on the box by the two forces? First one, okay, the total work, total, is equal to work done to move the box horizontally and plus work done to move the box vertically. So work done to move the box horizontally, you just take the force that pushing the box times with the distance, because work is equal to force times distance, move in the direction of force. So it's times 2.4 and plus, now the box is being lifted out, right? Lifted out, you just put mgh. Mg is already been given, which is the weight of the box, which is 40 times the height, 1.6. So when you work it out, you should get 112 joules, and I round it off to 110 joules, which is B. Question number 18. Which statement about efficiency is correct, right? Yes, A, efficiency doesn't have a unit. This is true. B, joules is a unit. No, joule is not the unit of efficiency, right? If efficiency is just the ratio of output power, useful output power to input power. If you want to times 100% to see the percentage of efficiency, yes, you may do that. Else, you just take the ratio of the useful output power per input power, or useful output work divided by input work, or the useful output energy divided by input energy. Right? That is why it has no unit. A is the answer. Question number 19. A plane wave of amplitude A is incident on a surface of area S, placed so that it is perpendicular to the direction of travel of the wave. The energy per unit time, this is actually power, right? Reaching the surface is E. The amplitude of a wave is increased to 2A, and the area of the surface is reduced to 1 over 2S. How much energy per unit time, or the power, reaches the smaller surface? Now I have to come up with the equation. I define intensity first. Intensity is defined as power per unit surface area, but intensity is also directly proportional to amplitude square, or I put a constant times amplitude square. So I can also say that power over area is equal to constant times amplitude square. A is amplitude. So now I have to replace it. This is area. This is A, amplitude. So power for the first part of the sentence here, they give us the power as E, surface area as S, equals to a constant. Amplitude is just A. So I will just put A square. I put this as first equation. Now the amplitude of the wave is increased to 2A. They ask you to find the energy per unit time. I'll just put power. So surface area is reduced to half S. Amplitude now becomes 2A, but the 2A, you have to square the whole thing. Therefore, I have P is O over 1 over 2S is equal to K 4A square. This is the second equation. I use the second equation, divide the first equation. P over 1 over 2S, this one I straight away invert it, S over E is equal to K 4A squared divided by KA squared. Now, S and S I cancel, A squared, and KK I cancel off. I have P over 1 over 2E is equal to 4. P is equal to 1 over 2E times 4. That is why the power, or the energy per unit time, is equal to 2E. B is the answer. Question number 20. A steel ball is falling at constant speed in oil. Which graph shows the variation with time of gravitational potential energy and the kinetic energy EK of the ball? I will do for EK first, because kinetic energy depends on speed. It is half mv squared. Since the speed is constant, therefore the kinetic energy must be constant. It's either A, B, cannot be C or D because kinetic energy is changing. So this is wrong. This is also wrong. Now, between A and B, I have to do that. Since the kinetic energy is constant, the speed is constant, now I can use speed is equal to distance over time. Speed is constant. Distance is directly proportional to time. Potential energy depends on mgh, right? So the potential energy is constant when the distance is constant, right? So when the time is increasing, right, the drop or the change in the graph, because this is falling through the oil, right? So that is why the change in gravitational potential energy or the change in distance is proportional to the time. So longer the time, the change in the distance, yeah, is decreasing because it is getting closer, right? So that is why it is decreasing constantly, linearly. That is why B is the answer. Question number 21. When a force of 8 Newton, 0.8 Newton is applied to a spring, the length of the spring is 90 millimeter. When a force of 1.3 Newton is applied to the same spring, its length is 115 millimeter. The spring obeys Hooke's law. What is the spring constant of the spring? Now, okay, for the spring constant, because two statements are given, they actually want us to form an equation. Obey Hooke's law. Hooke's law states that F is equal to Kx. X represents the extension of the spring. Now I have to do it one by one. So first one is 0.8 Newton, and this is a spring constant. But they say the length of the spring becomes 90 millimeter. They didn't give us the initial length of the spring. That is why I have to use 90 minus initial length of the spring. L initial. And I put that as my first equation. Now, when the force is 1.3, final length of the spring is 115, sorry, 115, and initial length is not being given. Second equation. I use the second equation, divide the first equation. I get 1.3 divided by 0.8 is equal to K. 115 minus initial length over K 90 minus initial length. Now I work it out, K and K, I'll just cancel it off. This is 1.3 times 90 minus length initial is equal to 0.8. 115 minus length initial. So I get my initial length first. Right, my initial length, when you work it out, your initial length supposed to be, okay, I'll do it then. So 1.3 times 90, I get 117 right here. 117 minus 1.3 initial length. 0.8 times 115, here I got 92 minus 0.8 initial length. So I'll just put, okay, 117 minus 92. This is 25 is equal to 1.3 minus 0.8. Work it out on the 0.5 initial length. My initial length would be 25 divided by 0.5. I get 50 millimeter as my initial length of the spring. Now, okay, to find the spring constant, I have to use F equals to Kx. So it depends on which F you want to use. When you was 1.3, you use 1.3. It doesn't matter. So F, I use 0.8, spring constant, because the unit of the spring constant must be Newton per meter. That is why 50 millimeter, I have to change it to meter. So I times 10 to the power negative 3. K is equal to 0.8 divided by 50 times 10 to the power negative 3. And I got 20 Newton per meter. D is the answer. Question number 22. An experiment is carried out using a metal wire to investigate how it responds to a varying tensile force. The cross-sectional area of the wire is constant, which graph has a gradient that is equal to Young modulus of the metal. Now, Young modulus of the metal, if you still remember, Young modulus is equal to stress over strain. So it is the gradient of stress-strain graph. C is the answer. Question 23. For a wire, Hooke's law is obeyed for a tension F and extension X. Young modulus for the material of the wire is E, which expression represents the elastic potential energy stored in the wire. Now, elastic potential energy, when you plot Fx graph, it is a straight line graph because it obeys Hooke's law. From a graph that is plotted, there are two information that you could obtain from the Fx graph that I sketch here. One is the gradient of the graph, which represents the spring constant, and the area under this graph represents the elastic potential energy. So the area is the area of triangles, therefore elastic potential energy is half Fx, which is C. Question 24. A plane polarized wave has an amplitude A. The wave is incident normally on a polarizing filter. The transmission axis of the filter is at an angle theta to the plane of polarization of the incident wave. What is the amplitude of the wave that emerges from the filter? Now, I want you to recall this equation. Cos square theta, Moore's law, I is equal to I naught cos square theta. Now, I is also directly proportional to amplitude square. I can say that I is equal to a constant times amplitude square. Right, that is why I can replace my I here with amplitude square and I naught with amplitude, initial amplitude is, okay, A. Now I'll just say this is a new amplitude. I'll just put here A new square. This is A square cos square theta. Now to find a new amplitude, I'll just square root everything A square cos square theta, and I get A cos theta, which is A. Question number 25. An electromagnetic wave is traveling through vacuum. What could be the wavelength and the period of electromagnetic wave? Wow, okay, traveling through vacuum, right? Wavelength period. You know, this is kind of confusing, but don't ever get confused. Recall the simplest equation, wave speed. V is equal to F lambda, if you remember. Now, V is equal to, F is 1 over period times the lambda. Now, okay, V is equal to lambda over T. Can you see? I get a relationship between wavelength and period. Now, because this is the electromagnetic wave travels through vacuum, speed of all the electromagnetic waves in vacuum as well as in air must be equal to 3 times 10 to the power 8 meter per second. Remember that? That is why we are going to do this one by one. I have to take, for A, I have to take wavelength, which is 1.2 times 10 to the power negative 10 tera. Tera is 10 to the power of 12. Divided by 2.5, mega is 10 to the power 6. So this one I simplified a bit. 2 over 2.5 times 10 to the power 6, you should get 4.8 times 10 to the power negative 5 meter per second. It is not even close to 3 times 10 to the power 8. That is what I'm supposed to get. A is wrong. What about B? 1.2 picometer. Pico is 10 to the power negative 12. And then divided by 2.5 times 10 to the power 11. Giga is 10 to the power 9. Right, so this one will become 1.2 times 10 to the power negative 12. 2.5 times 10 to the power of 11 plus 9, 20. So you end up getting, this is negative. Okay, so you end up getting 4.8, sorry. 4.8 times 10 to the power negative 33 meter per second. It is also not the answer. Now C, this is 1.2 times 10 to the power 2 pico is 10 to the power negative 12 divided by 4 times 10 to the power negative 10. Nano is 10 to the power negative 9. So this will give you 1.2 times 10 to the power negative 10 divided by 4 times 10 to the power negative 19. So you end up getting 3 times 10 to the power of 8 meter per second. I get exactly. Okay, that is a good news. C is the answer, but I'll prove that D is wrong. So for D, this is 1.2 times 10 to the power of 3. Micro is 10 to the power negative 6 divided by 4 nanosecond, negative 9. So here I get 1.2 times 10 to the power negative 3 divided by 4 times 10 to the power negative 9. I get 3 times 10 to the power of 5 meter per second is meter per second. So definitely this is not the answer. The answer is C. Question 26. Light of frequency 6.7 times 10 to the power of 14 Hertz in a vacuum is incident normally on a diffraction grating that contains 4 times 10 to the power of 5 lines per meter. What is the angle between the adjacent second and third order of intensity maxima? So I would do it, okay, a free space here. So for the second maxima, so I have to find the angle between undeviated beam and the second order first. And then I need to find the angle between undeviated beam and the third order first. Then I take the two value, I just find the difference, right? So they actually want you to find this. This is a, okay, diffraction grating. And then this is a screen. So you have undeviated beam. This is a second order. And this is the third order. And they want this angle, right? So I have to do it one by one. Now, here, I am going to find frequency. Okay, I'm going to use d sine theta is equal to m lambda. D is 1 over n. Sine theta is equal to m lambda. So for the first one, I have to find the wavelength first because the wavelength is not being given. To find the wavelength, because this is the light travel in a vacuum. So light with the speed of light, which is v equal to f lambda, 3 times 10 to the power 8 is equal to frequency, which is 6.7 times 10 to the power 14, and the wavelength. Wavelength is equal to 3 times 10 to the power 8 divided by 6.7 times 10 to the power 14. So my wavelength is 4.48 times 10 to the power negative 7 meter. So for the second order, I'm going to do here, second order, 1 over 4 times 10 to the power of 5 sine theta is equal to 2 lambda, negative 7. My lambda for the second order is equal to 21 degrees. For the third order, 1 over 4 times 10 to the power 5 sine third order, theta third order is equal to 3 times 4.48 times 10 to the power negative 7. Theta 3 is equal to 33 degrees. Therefore, the angle between the second and the third order is equal to theta 3 minus theta 2. 33 degrees minus 21 degrees, that gives you 12 degrees. A is the answer. Number 27, the siren of a moving police car emits a sound wave with frequency 440 Hertz. Stationary observer hears sound of frequency 494. Speed of the Hertz. The speed of the sound in air is 340 meters per second. What could be the speed and the direction of movement of the car? Since the frequency heard by the observer is larger than the frequency of the police car itself, that is why I say police car is coming towards the observer. So cancel A and C. Yeah, just lock your answer to B and D. So we use the Doppler effect. Observed frequency is equal to frequency of the source, which is the siren of the police car, times the speed of sound in air, V minus V source. Now, frequency is 494. Frequency of the source is 440. Speed of the sound is 340. Now, 340 minus the speed of the police car. You work it out. 494 times 340 minus speed of this is equal to 440 times 340. So the speed of the siren or the speed of the police car is actually equal to 37.17 meter per second. So I round it off to 37 meter per second. B is the answer. And it is coming towards the observer. That is why the observed frequency is increasing. Question number 28. The diagram shows the shape at one instant in time of part of a stretched string as a wave travels along it from left to right. Oh, this is very important because the wave is traveling from left to right. What are the direction of the velocities of the points 1, 2, 3 on a string at this instant in time? This is a transverse wave. Right? When they have already mentioned that this wave is traveling from left to right, that also means that the wave profile is moving from left to right. So I'm going to draw a new wave profile and I'm going to see where is the direction of vibration of point 1, 2, and 3 on the string. So I'm going to draw a little bit, okay, as if the wave profile is shifted to the right. Could you see that? So because the wave is moving, that is why the wave profile must be moving as well. Now look at the first particle. Yeah, compared to the new wave profile that I drew, first particle must be moving downwards. What about the second particle? Must be vibrating upwards. Third particle moving downwards. Down, up, down. Down, up, down. D is the answer. Question number 29. Which wave cannot be a longitudinal wave? Which wave cannot be a longitudinal wave? Answer is B, because longitudinal wave can never be polarized. That is one of the difference between longitudinal wave and transverse wave. Question number 30. Microwaves are emitted from two sources at point X and Y. The two waves meet at a point Z. The diagram shows the paths of the two waves. The waves emitted from point X and Y are coherent, right? Coherent means they have zero phase difference or constant phase difference. What is the direct consequence of the two waves being coherent? Let us see. There is a constant difference in the path length YZ and XZ. Constant coherent is constant phase difference or zero phase difference, nothing to do with the path length, path difference, no. So B, there is a constant difference in the phase between the two waves at Z. This is true. C, there is a constant non-zero difference in frequency, nothing to do with frequency, nothing to do with amplitude. So B is the answer. Now, 31, what is the unit of resistivity? If you remember, resistance is equal to resistivity times length divided by area. So put resistivity as the subject, RA over L. The unit of resistance is ohm. The unit of A is meter square over meter. So you have ohm meters square times meter negative 1. Therefore, you get ohm meter. Because 2 plus negative 1, you get 1. D is the answer. 32, a kettle is connected to 250 volt main supply. What are the possible values for the power of the kettle and the current in the kettle? Now, since we need to get volt, right, of 250 volt, you have to recall the equation of power. Power is equal to IV. V is equal to power over I. I need to get 250. So for the first one, 500 divided by 0.5, power divided by current, I got 1000 volt. This is not true. For B, I have 500 divided by 5. I got 100 volt. This is also not true. For C, I have 2,500 watt divided by 0.1 ampere, and I got 25,000 volt. This is also not true. And for D, 2,500 watt divided by 10, and I got exactly 250 volt. This is the correct answer. D is the correct answer. Question 33. Which circuit results in output voltage increasing with increasing temperature? So this output for A output voltage is actually measuring the input voltage. So that is not true. For B, right? So I look at B output voltage. Okay, I'm using potential divider concept. V output over V input, which is this one, is equal to R output over R total. Now, V output here is my V output over V input. R output is the R of the thermistor over thermistor over R total is the R thermistor plus load resistor. Now, if the temperature is increasing, okay, the resistance of the thermistor will have to decrease. So V output, you look at the V output here, it depends on the R of the thermistor. So the R of the thermistor is decreasing. I don't want my R to decrease because I want my voltage output to increase. R thermistor is decreasing, V output would decrease as well. B cannot be your answer. What about D? D has no thermistor here, so it does not depend on the temperature. What about C? Let us look at C. This is the R thermistor. When the temperature is increasing, the resistance of the thermistor is actually decreasing. And Ohm's law, potential difference is directly proportional to the resistance. Since the resistance of the thermistor is decreasing, the potential difference across the thermistor is also decreasing. But the total potential difference, or the V input, is equal to V of the thermistor plus V output. Since V input must be constant because they didn't mention that it changes cell, but V thermistor is decreasing, V output must increase in order to achieve the balance. C is the answer. Question number 34. 4 resistors, each of resistance R, are connected as shown. The total resistance between point X and point Y is 120 ohm. What is the magnitude of resistor R? You could see that X and Y, these 3 resistors are connected in series, which is parallel to this R. Now, in series, I just add them all and parallel with R. So I have the total resistance 1 over R total is equal to 1 over 3R because these 3R are in series plus 1 over R. 1 over R total, which is 120, is equal to 1 over 3R plus 1 over R. So 1 over 120 is equal to 4 over 3R. Cross multiply, 3R is equal to 480. R is equal to 480 ohm divided by 3, which is equal to 160 ohm. C is the answer. Question 35. A cell with internal resistance is connected to a variable resistor R as shown. Resistance of R is gradually decreased. How do the current I and the terminal potential difference across the cell changes? Now, current, because the resistance is decreasing, that is why the overall resistance is decreasing. Resistance is inversely proportional to I. When the resistance decreases, the current will have to increase. It's either C or D. Now, potential difference, the terminal potential difference across the cell. Since, okay, I will put EMF of the cell is equal to potential difference across the terminal PD, terminal, plus PD across internal resistance. Now, EMF is constant. Current is increasing. Therefore, the PD across the internal resistance is increasing. Terminal PD will have to decrease in order to achieve balance. C is the answer. 36. The diagram shows a circuit with a cell and 3 resistors, which resistances R1, R2, and R3. The cell has negligible internal resistance. The total resistance of the circuit is RT, which equation for RT is correct. For RT, okay, this is 1 over RT is equal to 1 over R1 plus R2 plus 1 over R1. Now I cannot choose A, that's wrong. RT, which is no, this is also wrong. I get to get back the equation that I have here. D is the correct answer. Question 37. Hydrogen and deuterium can be represented by the nuclide symbol 11H and 21H, respectively. What is the difference between hydrogen and deuterium? A, the deuterium atom has twice the number of electrons. It is actually equal because the number of electrons is the same because this atom is neutral. So the number of proton must be the same as the number of electron. This is wrong. Cannot be twice, must be the same because deuterium and hydrogen are both having the same atoms, number of atoms. B, the deuterium nucleus has a charge, but the hydrogen nucleus has no charge, actually no charge for atom because they are neutral. The deuterium C. Oh yeah, it is about the nucleus. Okay, if it is about the nucleus, the deuterium nucleus, right? It is 1. Look at the charge of a proton. This is 1 proton, and hydrogen is also 1, right? That is not true as well. C, the deuterium nucleus has less mass than the hydrogen nucleus. Deuterium has 2 mass, right? Compared to hydrogen, that is only 1 mass. Nuclear number represents the mass. This is also wrong. D, the deuterium nucleus has half the charge per unit mass. Deuterium is half charge per unit mass, which is half. Hydrogen is 1, right? Yes, this is true. D is the answer. Question 38, a radioactive sample decays by emitting beta-negative particles. The energy released in the decay process is the same for each nucleus that decays, but the beta-negative particles emitted have a continuous range of kinetic energies, which is true. Which statement explains why the beta-negative particles are emitted with a continuous range of kinetic energy? Right, okay. I would say that let us look at A. Some of the energy released is given to the remaining nucleons of the nucleus. Actually, that is not the answer for why the beta-negative particles have a range of kinetic energies. B. Some of the energy released is taken by an emitted antineutrino. When beta-negative particles are being emitted, it is along with antineutrino. This is true. So see, some of the energy released is used to create. There is no creation of beta-negative particle. D, some of the energy released is used to create a new nucleon. There's no creation of the new nucleon. Therefore, the answer is B. Question number 39, which particles is not fundamental particle? The one that is not the fundamental particle is neutron because it contains quarks. Up, down, down quarks. Question number 40, what is the charge of anti-top quark? So before we find anti-top, we need to find the charge of the top quark, which is plus 2 over 3e. Anti or anti-top quark, anti-positive is negative. A is the answer. So that's the end of our discussion for May June 2024. Paper 1-1. I hope you gain benefits from here, but if you have any idea or any questions, do comment below. Thank you very much for watching. Bye.